So there we have some foundation now for movement and how it relates to derivatives. So physicists are interested in movement, not just in diving things or flying objects, but objects like protons and neutrons and atoms and how they move and we want to simplify that to something we called one-dimensional movement. All right, so we talk about things flying around space as pretty complicated, things flying all over in three-dimensional space, but let's simplify it and talk about things in one-dimensional space. All right, one-dimensional movement means we got a point like this guy right here stuck to a line, and this point's kind of moving about a little bit, and its movement looks like it's governed by some function. Okay, it's moving right during some of the time. It's moving left, then it's moving right again. And if you watch, it's speeding up and slowing down, and then it's speeding up, slowing down, speeding up. So it's changing velocity, it's changing position, and it's changing acceleration. So everything's changing here. So we want to be able to study this and apply our calculus to it here, all right? So this one-dimensional movement, we got this point. Think about it moving on a line. It's got a position. We'll call it x of t. That's its x coordinate at some point. It has a velocity, whether it's moving right or as this guy goes, it's moving left at some time here, all right? And it also has an acceleration that we can look at. All right, so let's investigate this a little bit here. So this has a function. Here's this function that we're looking at. 1/3 x cubed minus 7/2 x squared plus 10x plus 10. And that's governing the position of this. All right, so that's the position. Sometimes we want to figure out how far it's moved. We call that displacement. That's a change in position, or the x of b minus x of a for this interval a to b. If we're looking at the velocity, if velocity is positive, it's moving right. If velocity is negative, it's moving left. All right. Acceleration, well, if acceleration is positive, that means it's accelerating towards the right. If acceleration is negative, it's moving or it's accelerating towards the left. We'll see how that works in a moment. And something to note about speed here. Speed is the absolute value of velocity. All right, so direction doesn't matter. Velocity is going to be, it has direction and it has speed. Speed is just that absolute value. It's going 2 feet per second or 2 units per second or whatever it may be. All right, now we're going to see if it's increasing in speed, then the velocity and acceleration will be in the same direction. They're like playing a tug of war. Decreasing speed if they're going in opposite directions. Okay, well, let's think about this here. So here's our function that we just saw. And these should be t's here, a little typo there. All right, we'll roll with it here. So these are x of t. So these are t's. All right. So the question is, what's the displacement for the first 6 seconds? Well, displacement is how far it's moved. Okay, so we can say our displacement is x of 6 minus x of 0. Okay, where is it at these different times? Well, at x of 0, that one's easy to find. Plug in 0, 0, 0. All this wipes out, and we're left with 10. And x of 6, I went ahead and figured that out. Plug that in, it comes out to be 17. Okay, just use a calculator. 1/3 times 6 cubed, 7/2 times 6 squared, so on and so forth. All right? So the displacement is 7. Okay, now let's see. We have time, but we don't have a length. It's not necessarily in feet or inches, so we'll just say 7 units of length there. All right. Well, when is the point stopped? Well, because we have this nice graphic, we can see it. It does stop at some points. When is that? Well, it looks like about at 5-ish, maybe. It's kind of hard to tell. because the point's in motion. Well, let's find the function. So when is it stopped? Well, stopped means the velocity is 0. That's when something is stopped. It has no velocity. Well, how do we find velocity? Velocity is the derivative of the x function or the position function. So we want the derivative of x of t. All right, and that's going to be t squared minus 7t plus 10. And we want to set that equal to 0. And we're in luck. I think this thing factors t minus 5 and t minus 2 equals 0. That's great. It factors. Set this equal to 0 and this equal to 0. We have 2 times. So that happens when t is 0. Nope, sorry. T is 2 seconds. And t equals 5 seconds. So there's our 2 times when it stops, and we can look at our graphic and see, yeah, I think that's about right. The time here, watch the time it's going to start over. It's about 2 seconds it stops, and about 5 seconds it stops. Yep, that's exactly right. Well, when is it moving left? Well, leftward movement here means that the velocity is negative. So the velocity is 0, less than 0. Well, here we can kind of use a number line. And so this will be our velocity number line. We know that at 2 seconds it stops, and at 5 seconds it stops. Now, let's imagine we don't have that graphic. We'll check here in a second, but we can just do what we did kind of with curve sketching. Plug in some numbers, all right? Plug in something like a 0. If you plug in 0 here, or maybe like 1, because 0 is when it really started. So we should probably plug in like 1. Plug in 1 for velocity. Here's our velocity function factored. The velocity equals this. So 1 minus 5 is negative 4 times negative 1. Negative times a negative is a positive. Plug in something like 3. If you plug in 3, you get positive times a negative. Positive times a negative is a negative. Plug in 6. Positive, positive. Okay? So what does that mean for us? This is not necessarily curve sketching, okay? This is direction. So since this is velocity, this means we're going right, left, and right. Positive is the right direction towards the positive numbers. Negative is the left direction towards the negative numbers. So when is it moving left? In this case, it's moving left on the interval 2 to 5, or we might say t is less than 5 and greater than 2. Okay. When is it moving right? Well, we can use the same number line there. That's what we found out. So it's moving right from 0 to 2 and from 5 to 10. Or we might say t is less than 2 is less than 0, and t is less than 10, less than 5. During those time intervals there. All right, well, what is the point speed now at 3? Speed, remember, is the absolute value of velocity. Okay, now actually let's go look at this here. And let's see if this is, according to this, backing up a bit, is moving right, left, right. Is that what our graphic is showing us? Our little picture is moving right, then left, then right again. Yep, that looks good. Okay, point speed at t equals 3. Okay, well, that's the absolute value of v of 3. And v of 3, we can use our velocity function, either the factored version or the non-factored version. Okay, well, I'll use the factored there. So the absolute value of 3 minus 5 times 3 minus 2. And that's going to be the absolute value of negative 2 times 1, which is going to be the absolute value of negative 2, which is 2. So this is 2 units per second. So that is our speed. Now, even though it's moving left, okay, so really the velocity is negative 2, but the speed will be positive 2. Then last thing, is it speeding up or slowing down? Well, the velocity of 3 we kind of just found out there. This is the velocity, negative 2 times 1, so it is negative 2. But what's the acceleration? Well, the acceleration function, let's find that. So we've got to find the derivative. That's going to be the derivative dt of the velocity function. Where's our velocity? It's up here, t squared minus 7t plus 10. T squared minus 7t plus 10. Take the derivative, we get 2t minus 7. So what is a of 3? That is going to be 2 times 3 minus 7, which is 6 minus 7, which is negative 1. So what's going on? We have a velocity at negative 2 and an acceleration of negative 1. Well, does that mean that it's slowing down? Because negative acceleration seems like it's slowing down. Well, we've got to be careful there. This is moving left. And a negative acceleration means it's pulling, think of it like a tug of war, it's pulling to the left. So if you've got a point on the number line and it's moving left, the velocity is going left, and the acceleration is going left, well, the acceleration is pulling it, and it's already moving that way, so it's being pulled in the direction. So this is going to be speeding up, all right? Or the speed is increasing, all right? If those were going in opposite directions, then the speed would be decreasing. So at 3 seconds, the speed is increasing in this case. All right, so that's one-dimensional movement there. So something that will show up a lot on the AP test. Guaranteed that there will be some one-dimensional movement. So great job. Hopefully that helps. Now you can go get those derivatives moving on some velocity and acceleration.